All right, now we're having a look at question 3. We're using trial and error to find the zeros of each of these and then express it in factored form. Now, the key is if you can manage to find as many zeros as the degree, then you don't, you're pretty much done. So each of these is degree 4. So if we can find 4 zeros, then we don't actually need to do the long division. We can literally just write it out. But if we don't find 4 zeros, then we're going to have to actually do the long division. So we've got, the first thing we do is we look at the last number, because the zeros are likely to come from the factors of that number. So for 3a, well, positive 3 equals positive 3 times 1 and negative 3 times negative 1. So we'll try 3, 1, negative 3, and negative 1. So P of 1 equals 2 times 1 to the 4. Actually, I'm going to do this in brackets. I'm going to write it exactly how you should in your calculator. 2, 1 to the 4, take 5. 1 cubed, take 5. 1 squared plus 5. 1 plus 3. Chuck that in your calculator. What does it come out as? 0. 2 take 5, plus 5. Plus 3, yep, 0. Okay, now let's try minus 1. So we're going to go backwards in our calculator and replace all those positives with all those ones, like we're going to put minuses in front of all the ones. So that's going to be 2 plus 5, take 2 plus 5, plus 5, take 5. Plus 3. It's going to also be 0. Okay. So x take 1, so x plus 1. Okay, we've found 2 of our zeros. We're on a good streak. The next one we're going to try is positive 3. Actually, no, let's try a negative 3 next. So we've got 2 times negative 3 to the 4, take 5. Negative 3 cubed, take 5. Negative 3 squared plus 5. Negative 3 plus 3. I'm actually going to do this time. To the 4, take 5 times negative 3 cubed, take 5 times negative 3 squared, plus 5 times negative 3 plus 3. 240, which is not 0. So it's not a factor. Okay, now let's try positive 3. So I'm going through replacing all the negatives, deleting all the negatives. And it's 0. So x take 3. So we know P of x equals some kind of number times x take 1, x plus 1, x take 3. We're trying to find this number. The only way we can do that is long division. Now, again, we could divide it 2x to the 4, take 5x cubed, take 5x squared, plus 5x plus 3. We could divide it by each of these individually, and then x take plus 1, and then x take 3. That's going to take so much longer than if we just multiplied these out and then divided by that answer. So this thing equals x squared, take x plus x, take 1, times x take 3, which is x cubed, take 3x squared, take x plus 3. So we're going to divide by that. X cubed, take 3x squared, take x plus 3. We're going to divide by this thing. Okay, how many x cubes go into 2x4? 2x cubed. Multiplying right below, 2x to the 4 takes 6x. Oh. 2x of them, sorry. Yep. 2x to the 4 take 6x cubed. Take 2x squared plus 6x. Subtract and drag down. X cubed. No. Have I totally stuffed this up? No, I don't think so. Okay. 1x cubed. Take, and I'm plussing 3x squared. Take x plus 3. Okay. How many x cubed go into x cubed? One of them, multiply out. X cubed, take 3x squared, take x plus 3, subtract. And obviously we're going to end up as 0. So therefore, P of x is all these brackets, x take 1, x plus 1, x take 3. But we found the blue bit. The blue bit is 2x plus 1. All of the rest you're going to do like that.